Okay, how you doing? We're going to talk about addition and subtraction properties of radicals. So up here I have essentially the basic form of it is that I have x times some root k of a plus or minus y of some root k of a. And what I want to point out to you here is that I'm just trying to say to you that the k's are identical, so I must have the same root for this to apply. I can never add roots together that are of different indices. So meaning if this was a 2 and this was a 3, this doesn't apply. So it only applies when you have the same root being applied together. But essentially what I'm saying to you is you take the values that are in front of the roots and you either add or subtract them based on the property that you have. So that's what this means over here, that you add or subtract the, for lack of a better word, coefficient of the radicals, and that's how you do it. So again, just a very bare basic example here, that if I take a look at this, that applying this, I add or subtract these two in front. So what is 4 minus 6? Well, it's negative 2. And the important part here is to understand that this does not change. So the root does not change. I'm literally just saying how many of that root I have or what the value of that root is worth. So in this case, I have negative 2 times root 5. And that's my final answer. There's nothing more that I can do. That's it. So I hope you understand that. So here we go. Let's make it a little bit more complicated. The only way I can make it complicated is to add a little bit more into it. But I'll make these a little bit harder and harder and harder as we go along. So here we go. On to the next one. So we have 4 root 2 plus 3 root 3 minus root 2. So again, here we go. Using this property, root 2 and root 3, I can't add 4 and 3 together because that's a 2 and that's a 3, which means I'm saying to you that these radicands must be identical. If the radicands aren't identical, then I can't add them. And if there's nothing I can do to reduce this to write it into a simpler form, and that simple form goes back to this, there's nothing more that I can do besides leaving it like that. However, what I do have over here is I have a negative root 2. Negative root 2, again, is kind of like a negative 1 root 2. So I can go 4 minus 1, which is 3. So I have 3, and I have a root 2. So I have 3 root 2 plus, and in this case, I have 3 root 3. And that's how I'm just going to leave my answer. Yes, some people would say, oh, you can factor out a 3, but I'm going to leave my answer just like this. So that's how I'm going to leave my answer for this one, because all I want to demonstrate is the addition property here. So on to the next one. Next one says 5 times root 12 plus 6 root 3 minus the root of 48. Now, someone might look at this right away and go, oh, there's nothing I can do, there's nothing I can do here. Well, remember in all my previous videos when I was talking about multiplication, that I was saying that you must leave it in simplest form, meaning that if there is a factor of this number that is a square number, I must remove it from that problem. So, what I want to check, are there any factors of 12 that are square numbers? And the factors of 12 that are a square number in this case is that I have 4. So this is really the square root of 4 times the square root of 3. So I want to write it like that just for a moment to show you that I'm really going to do square root of 4 is 2. 5 times 2 is 10. So I'm left with 10 root 3. I'm adding to that 6 root 3. So all of a sudden, aha, I do have something that I'm going to be able to add. But I want to make sure I write them all in simplest form. So coming over here to this last one, I want to know, are there any factors of 48 that are squares? Now, I can look at this and go, yes, there are. And I can look at it and go 4. But I always want to try to find the highest if possible. And I want to see what are the highest square numbers. So 4, sure, 4 goes into it, but I want to check there's a higher one. How about 9? No. 16, aha. 16 goes into it, but is there a higher? 25? No. 36? No. And after 36, I'm at 49. So no. So the highest one I found here is root 16. So 48 is root 16 times root 3, which is nice for us based off of what I've worked here. So I get square root of 16 is 4, so this is minus 4 root 3. Now, what I can do here is I can begin to add the values in front and leave it as a root 3. So the important thing here is, how many root 3's do I have? So I have 10 plus 6, which is 16. 16 minus 4 is 12. So I have 12 root 3. And then that's my final answer, as 12 root 3. So I hope you see what's going on here, but again, I'm just applying the very basic principles of this one. I use the multiplication property, and this one I use the multiplication property, which stated that if I have this idea of a times root b, that is equivalent to this a times b radical. So I'm saying that 48 is really the product of 16 and 3. So the factors of 16 and 3 I broke apart into this form, took the square root of 16, which was 4. So that left me with this answer. So the only way I can make this a little more complicated is to add ones that maybe don't subtract, or I just add numbers that might be difficult to look at. So here we go. Again, it's the same basic property, so you should always think about what can I do here. So the next thing I'm going to do is 2 root 75. So plus, so 5 root 52. And I'm going to make that a minus, why not? Minus 5 root 52, and then I'm going to do minus 6 root 117. And again, the hard part here is, one, you can use your calculator for these. And the only reason I'm using a calculator for this is because it would be quicker than doing it by hand in this case. Because all you want to do is check what if a square number is a factor of 52, is a square number factor of 117, is a square number factor of 75. So here we go. And in this case, I'm going to take a look at this. I'm going to go, okay, is there a number that is a square that is a factor of 75? And in this case, yes. So I'm going to write this just in little work below it as square root of 25 times the square root of 3. So I've got the square root of 25 is 5. So 5 times 2 now makes 10. And I'm left with root 3. So minus. So again, my work. 52. Is there a number that is a square number that goes into 52? And in this case, yes, there is. It is the square root of 4. 4 and 13 makes 52. So this is square root of 4 times the square root of 13. So 5 times 2, because the square root of 4 is 2. What's 5 times 2? It is 10. So I'm subtracting 10 root 13. And the last thing I come over to is I look at this. I go, okay, I have negative 6 is 117. Is there any square number that goes into 117? And again, all you simply have to do is 117 divided by 4. Nope, doesn't work. 117 divided by 9. Aha, it does. So you get the square root of 9 times the square root of 13, which is 117. So now I have the square root of 9, which is 3. 3 times negative 6 is negative 18. And I'm left with root 13. Now looking at this, is there anything I can combine now that they're in their simplest form? And yes, lo and behold, I have negative 10, negative 18. But this root 3 it can't combine because this is a root 13 and this is a root 13. So I can only combine those two. So I'm left with 10 root 3 minus 28 root 13. And then from here, there's nothing more I can do. That's it. I'm done. So I hope that helps with the addition or subtraction property of radicals, but you just apply that over and over and over again to different problems.